We're just going to wait a couple more minutes before we get started and give our straggler friends a chance to hop on. So we'll start at 12:02. Okay, so we're going to get started now. It looks like we have lots of folks waiting. So thanks again for joining us for another Roth IAMS webinar. This week's topic is out of sight, out of mind. I'm just going to share the housekeeping notes as we get started. For everyone on the line, if you have questions or thoughts that you want to share at the end in the Q&A section, please feel free to put them in the chat. And when we get to the end, when we do have time for Q&A, we will address them then. Also want to mention that, yes, at the end of this, we will be sending out a follow-up that will have a link to the deck and the recording, so you can watch those at your leisure. Housekeeping notes also include, we will have some poll questions in the presentation, so please participate in those as they help us understand more about our audience. At the end, we will have a webinar survey that we asked you to take so we can continue to see what you're interested in and what webinars we can bring to you. So now, without any further ado, I'm going to turn it over to our latest VP at Roth IAMS, and that is Mark Schrock, to take you through his presentation, Out of Sight, Out of Mind. Over to you, Mark.
Thanks, Amanda. Hey, we're going to talk about some things today, and we're going to start out with a quick intro, and I'm going to set the table. There's a lot to digest here. We're going to do a comparison of horizontal infrastructure against vertical assets and frame them inside of a total cost of ownership framework. I'll use a foundational 5 roadmap that'll get us to our journey of discussion on risk mitigation, also on return on investment for this type of operation. I want to give you some tools and templates to take away. And finally, at the end, as Amanda mentioned, we'll be doing some Q&A. So my goal here is to help you think differently about stuff that we walk on, and that's versus the buildings that we see. Because when things don't give us trouble for a while, especially as facility managers and professionals, they do become invisible. So I started talking and forgot that some of us have not been properly introduced. So, who is this guy? My name is Mark Schrock. After about 40 years inside of design, build, construction, and asset management, I've learned the hard way that these risks are buried. They're out of sight. They are out of mind. I know this because I have been the one that's installed some of this infrastructure. I've I've assisted clients in assessing and managing infrastructure portfolios over the years, and I've directed software builds that integrate with existing client systems with legacy software platforms to track all of this information. And I want to share lessons from experience to show you how we can bring those hidden risks back into the light before they catch you off guard. So let's kick off with a poll question. Do you include horizontal assets, whether they're subsurface or surface, inside of scopes of work for your vertical facility condition assessments? Simply yes or no. Maybe a somewhat. Give it a second to let the votes come in here. Well, that is an interesting split. It's almost 25, 25 and 50, yes, somewhat, and 50% no. So hopefully we'll find some interesting places for everyone to get onto the same page here. Let me set the table before we dive in. Why does this matter? And I just have a simple explanation for you. It's because ignoring these types of assets is like ignoring a sinking foundation. It's fine until it's not. So think about this, right? We plan, we build, and then time passes. FMPs have taken over what we've built as constructors, and we've gotten into maybe a bit of complacency on these types of infrastructure issues because time has gone on, and most of these systems, they're just not screaming for attention for a long time. It can be decades, literally, before you hear from them. But when you do, they're creating potential for major operational risks. So can we talk about some excuses I've heard from clients as to why they're not in any position to tackle the issues? The biggest one is that we just don't do anything about it. We run to fail. That's our strategy. And my response to that is that hope is never a strategy, not with facilities. We allocate a fixed amount every year to deal with emergencies. We got a bucket of money, and that's how we're going to do it. And while that might work for a little while, what happens when the money runs out and there is substantial issues? So another is we don't have the information and we can't get it. We've got an old institution. We've lost all of the pertinent information. Is there any willingness or a desire to maybe start small and to cast a vision to keep that collection going, even if it's modest and it goes on for a while? We don't have the staff or the resources to keep this data updated. Well, do you have the funding to install a new? Maybe you're really busy, you're installing stuff all over the place. But if you don't have the resources allocated to collect the as-built data, the record drawing stuff, and get it in a place where everybody can use it, have you really allocated enough funds for this project or for these projects? And then the last one is that if infrastructure budgets, they're focusing our attention on short term, the more visible stuff. All that does is it increases your rate of decay over your assets, neglecting bigger issues. That is not going to end well. Reactionary emergency fixes are always way more expensive. They steal from everyone's budget. And so if this is your organization, I can promise you that you're not alone. 50% of the poll, they're not collecting this information. You may be discouraged, but there are solutions. We'll talk about those today. Our goal is to educate and educate towards proactive planning. So as one client summarized this cycle, we're underfunding what we are underestimating. And this is going to be our roadmap today. It's a 5-step framework. It's a repeatable process. Doesn't matter if your portfolio is big, if it's small, if it's horizontal infrastructure, whether you're tracking vertical assets. It's also scalable. From a high level look, you can get into a deep level of granularity inside of entire portfolios. I like to use the acronym DESAL. It's the discovery, evaluation, strategy, action, and the long-term planning. This process works. It's like building a clarity layer by layer. It's just like treating water through successive filters. It's a progression. The discovery, we're going to talk about and help understand what you have and why it matters. In evaluation, we'll examine this quality and the completeness of any existing data that you might have. We're going to build a strategy that includes alignment with leadership teams and helps define your plan over time. And then finally, a call to action. We'll figure out how the best way is to execute the work, to collect anything that's missing, the parts and pieces of data that you don't have that you want, and to do that with integrity and with verification. And then lastly, it's going to be a discussion around long-term planning, because we're going to tie all this together with TCO thinking, and we'll prove a return on your investment. A bit further in the presentation, I'm going to walk through each of these steps. I will show how they're going to help you to reduce risk, to quantify some ROI, and build defensible capital plans. So let's unpack how this applies to infrastructure. Facility teams, they're often separating assets into two worlds, the vertical and the horizontal. The vertical assets, these are what we see every day. They're the structures, the buildings. They're visible, they're accessible, and inside of facility condition assessments, they are typically the things that get assessed. However, horizontal assets, the tunnels, the subsurface utilities, stormwater, distributed electrical services, they're not visible, they're neglected. The irony, it's that the hidden systems are frequently the ones that make or break our service continuity. And to plan responsibly, we've got to treat them with the same discipline that we do our vertical assets. So I want to do another poll question. On the screen here, I've got a picture of a famous old building in San Francisco called the Ferry Building. If you're not familiar with San Francisco, that's the Oakland Bay Bridge structure in the background on the right. So my poll question, it's a bit of a trick question for y'all. Is a ferry building a vertical asset or is it a horizontal asset? And if you're not familiar with the structure, it's both a pier and a terminal. Foundations are all in the water. And then my follow-up question is the Bay Bridge, is it a vertical asset or is it horizontal infrastructure? Let me see your responses in the chat. Give me a second. Okay. Well, the answers to these are interesting. The ferry building is both. It is because it is a pier, it is considered partially horizontal. And the Bay Bridge, while it's a towering structure, it is horizontal. So let's talk about the fact that we need to agree at some level of consistency when we refer to assessments, especially when we go into evaluation of assessment data. At Roth IAMS, we use Uniform At2 system that's published by the ASTM. It's consistent categorization for both vertical and horizontal assets. And you'll see familiar vertical elements A through D. If you've been around these assessments, you see these elements. If you've been around Uniform At, which I'm sure most of you have. What gets neglected, though, are the elements F and the element G. That's where your special construction and your building site work lives. If you are looking at an industry standard for horizontal infrastructure, you're going to be able to normalize all your asset class data if you're collecting it in the F and G elements. It will be a big step towards integrated capital planning. I did a quick internet search, and result I got back here. BOMA is the industry standard for vertical assets and aging those assets, but BOMA doesn't provide standards for measuring the useful life inside of infrastructure, at least in the general sense. They don't have timings for roads, bridges, or utilities. And I found it interesting because the examples that I found, one of them in particular out of a BOMA publication, it shows parking lot decks and lots and surfaces. The average useful life in years was listed as life of building. And that example number 2 there, it's talking about subsystem categories such as horizontal elements, electrical rough-ins, and the like. And their living average life cycle is lifetime. So if these are correct, and this is what you're using when you're collecting horizontal infrastructure data, how can you possibly plan for them in your long-term capital budget when you don't know when they're going to fail? What about the bridge? I love this picture of this guy painting on the Golden Gate Bridge. It needs capital renewals and it collects deferred maintenance over time, just like anything else. And I believe that everyone has heard the story of painters, that are up there on that bridge. And apparently, they paint, they start at one end, they go down to the other, they come back. It's never ending. Well, apparently they are up there and they're up there painting every day. But the fun fact is that while it's not never ending, it's not down to the other end and back like the myth goes. Even if they concentrate on targeted work, and that is what they do. They concentrate on targeted work, but there's no set pattern besides this, is that they do the most corroded areas first. So they understand how to care for this and understand prioritization as they're up there working. I thought that was kind of interesting. So for a quick foundational recap, unit format isn't just about structure, it's also about level of detail. From a high, like a level 2, where we're talking about a roadway, down to a level 5 of a component, like when you're driving into the parking lot and you see a parking lot lighting pole and a fixture. This granularity is what enables us to build these defensible cost models and to build risk prioritization. When we know the expected life cycle of each of these at each level, it helps us because we can forecast the replacement timing and the cost. I'd rather than it being a surprise in the future by a failure. So to add to this, there's a universal truth in our industry, and that is that water always wins. There's corrosion, there's infiltration, freeze-thaw cycles. These forces are out there. They're quietly degrading our assets over decades. So I want to do just a quick introduction on total cost of ownership. I'm sure that a lot of people have heard this, but it brings me to the why of what we're doing, and that is the long-term capital plan. And just like utilizing industry standards to catalog infrastructure data, this is the emerging standard for strategic capital planning. There's a couple of reasons for this. And to develop the understanding here, I want to tell you why it's become main stage. It's because the total cost of ownership model, it realistically reframes the discussion. Our friends over at APA, they've done tons of research that show that about 80% of your cost to own a built asset, whether it's horizontal or vertical or hidden, which means that they're yet future. It comes after construction. So 20%, it's upfront cost. But we're missing the real story because it hasn't been written yet. True stewardship means budgeting for this entire life cycle. And there are a few layers of this that we want to consider. So let me go into how this TCO model works a little bit. The goal of the model is to show how one decision to address deferred capital and renewal maintenance for one asset affects the future state of all other assets. And to do that, you need a ton of data. And if you don't have a ton of data, it can be done through really good models, but you need one or the other to make this happen. We've discussed that TCO is necessary for responsible sustainability, but we want to go into our thinking a little bit more about strategic long-term planning, and we need to do that with our eyes open. There are real costs to collecting good data, and there are real costs to maintaining it. So in talking about data quality, an old client, he was a great partner and a colleague. He would say to me, Mark, a little of a lot is still a lot. And for his institution, accuracy absolutely matters. So the data quality, it mattered. Uh, the junk in, junk out, right? It's an old computer adage. Everyone is currently on AI bandwagon. How can we get AI into facilities? You know, whether it's digital twin or some other thing. And there is a misunderstanding, at least from my perspective, that how there is intelligence in a box that is smart enough to take lots of what I would call bad data and somehow make it really good, or to add even more bad data and make decent data better. Really, like how does that work? It doesn't. So um, we'll move on and talk about um, good data and the cost of that data. I think most of you have seen or heard of the iron triangle. It's a relationship to quality. It requires cost and time and a scope. You can't change the emphasis of one of these without affecting the others. So when funding's tight or you're having to cut corners, you've got future cost impact to those decisions and they get multiplied. So balancing this triangle is central to sustainable and data-driven planning. Now that we understand a bit of the foundation, let's talk about how we start changing the end of the story. Do y'all remember those Choose Your Own Adventure books? This is kind of like that, but the story is your story, and you're the main topic here. So let's walk through each step. Let's look at what it takes to make infrastructure data visible, measurable, and defensible. As I mentioned in the intro, discovery is the first step. We got to take stock of what we already know. So it helps if you can ask a couple of questions, what data that you already have that's available to you in the present. Is that data accurate? Is it current? Maybe it's spread across different systems locked up inside a different software. It's okay if it's not what it could be, or even what it should be. The goal here is to figure out what you have and to be honest about what you don't. The question to ask is also, who manages that data? Does anybody really own the sum of the parts? And how granular is it? Is it geotagged? Is it coming out of a GIS platform? Is it cost linked? Do you have cost data with it? Many institutions, they're going to find that their data is siloed. It's locked up in Excel sheets and possibly in GIS layers. Maybe CMMS platforms, maybe it's hard copy, it's old rolls of plans sitting in a closet somewhere. But discovery means pulling all of that together in whatever forms it's in to expose the gaps, to understand what's missing before you invest dollars in the wrong things at the wrong times. Now let's talk about evaluation. In this phase, I like to use the old who, what, where, when, how, and why. The who in all of this is who is responsible for that data. The what assets are included, which assets are not. Where does the data live? Those systems that we talked about. How can it be accessed? Who has access to it? The when and the how. When was it last updated? How was it collected? Is there multi-variable prioritizations, actions that are built into each row of data? And we'll talk more about that in a minute. The how much, this is associated current replacement values for each of your assets, down at the component level, even how much each component costs. Its condition and any known issues with cost to cure those issues and when that needs to happen. And then finally, the why. Why are we collecting it? What decisions will it support? The bottom line is that if we move away from apathy and we build awareness, we're going to figure out who has what. We're going to gather what we have, and we're going to improve from spreadsheets to structured relational data. That's going to end up inside of a software platform like our streamlined asset management software, SlamCap. That can be centrally accessed and updated. People can get on it from different regions. They can drive dashboards, they can push out projections, and it does automation that keeps the data fresh. So when you see 10,000 rows of properly structured data, you'll realize that how powerful that foundation can be for you. So getting started on this, I wanted to talk you through just a few steps on building your own quick spreadsheet. This will be for your infrastructure data. You can do this for your vertical data as well. But enlist help from your departmental professionals, from the people that are taking care of these assets day to day. Or you might find out that you're the one that's having to do this. Here's an example of what the start might look like. It's 3 columns, and we'll just keep building to the right from there. This thing can go out forever. So, but to start with, don't make this complicated. This is the first step of your internal discovery. So here's the what. We'll continue the example with data elements that we want to be able to reference through some granularity. I've done a properly structured data set here. You've noticed that the uniformat, the discipline, the system, the assembly at the top, followed by the uniformat level identified underneath it, and then cascading or waterfall of each of these data points as they roll down into the uniformat category IDs. This is super powerful. So the idea of this is that you can scale this effort. You can trim costs where you need to. Maybe you're looking at your parking lots and the striping. You could evaluate that striping for the entire parking lot. It could be sitting at a system level of just pavement markings in uniformat level 3. However, the asphalt itself, it probably needs more granularity down at the uniformat 4, uniformat 5. It's got a composite makeup. It's supporting soil and it's rock bridging, perhaps several courses of asphalt built up. And you need to show the related problems because you've got water infiltration happening. It's cracking. There's alligator cracks all over, and you're starting to see the subgrade failing through the asphalt. Well, you can't do that without logical catalog structure like the uniformat ID column. So to further continue the example, we also need to consider where these data elements are physically located. So can we find them? Can we fix them? How can we get Excel data from GIS systems? Maybe you're running space inventory management and you're covering parking stalls as well. How do we get those types of information out of legacy systems and into a structured data set? Well, the answer is a flat file. It's an Excel import export tool. And that's where we match up columns from both systems. We import the data in rows by a logical tie. And we need that logical tie to make this work because it's the piece that makes the data interchangeable between several different software pieces. It gets validated between the two systems. These two numbers, they're the only things that have to match in both systems as far as rows of data go. And then you can expand the data from there. You can overwrite the data row by row based on this logical tie. And for this example, maybe you have a geographic information system, and that's your institution's digital source of truth. Well, we can use that GIS asset ID to link on with our SlamCap software. We'll use that ID. And so together with those two ties, all of this becomes very, very plausible and helps these two systems to talk together. But in carrying the example out of doing this on your own, so we've talked through some of the structure. But you may decide that you don't have enough information on the location of every item that you're tracking, or maybe some items you don't know, and that's okay. But you may want to add a column for location description. You want editable text, and so add that column into your spreadsheet as well. Maybe you want to place XYZ coordinates from your GIS. Maybe you have that information, or you want the information, or you just don't have it yet. Or maybe you plan to start collecting it at some point. Add those columns as well. But for the when and the how, we need to consider the when of the assessment date, if it's known, minus the take action by in years. Most GIS data won't have this type of data beyond maybe description. And we'll need to figure out if we're going to deal with these issues of missing data. And that brings me to a quick discussion on data gaps and on data quality. Because understanding the data is important, or it just ends up being a bunch of numbers in an Excel spreadsheet. How do you evaluate that data? How do you evaluate the rows of data? So for example, here, I've got one line of data, and we've got to acknowledge in the date field, this data is 17 years old. We don't know the physical location. I'll use the example off of the previous slide, those XYZ coordinates. And after a quick analysis, we understand that maybe this data should not be trusted, at least not as much as something that's a bit newer and has more data in it. So you may want to add another column called confidence score, or data confidence. The example that I've placed here is a decimal form of a percentage, but that builds a filterable gap. It lets you float the things that you don't know or that you don't have confidence in up to the top when you do a sort on your Excel sheets. So just a couple of quick notes on gaps in your data. There will be some. Outdated information, there's going to be some of that too. Are you going to have low or no confidence data? Yeah, you're going to have that. Is there going to be data that's missing altogether? Yeah, there will be some. Also, AI is not going to be a substitute for you as well. Your institutional knowledge from your long-term staff, that's where a lot of this data potentially is going to live. Get them involved because as you're starting to collect this data, they may be the ones that can tell you that you're missing entire sections of data based on their institutional knowledge. Here's where most institutional data and systems stop short of using their data for planning. And we're going to build on the example here and what we need to consider when we're talking about the effects of cost, especially if we're going to build actionable long-term plans and that they can be updated over time. See, GIS systems, they're probably what most institutions use for this infrastructure data. They don't do cost well. That system wasn't designed to. You can make it do it maybe for a while, but it will not be able to maintain things like fluctuation in commodities pricing, escalation, or project planning selections that you do over time, funding streams, or looking out 50 years into the future, updating that stuff in GIS. We've got to get that GIS data that you currently have out of GIS into a flat file. And from there, you can evaluate it, you can edit it, you can include cost data, and you can import it into FCA software like SLAM. And that's where cost can be applied item by item inside of Uniformat ID. It can be done in bulk, it can be done in batches. You can adjust all of those costs instead of going through a GIS system where you just have line after line after line. I worked with one client, 40,000 rows of GIS data. Can you imagine updating that by hand? Especially for cost, it would take you, you'd be the painters on the Golden Gate Bridge up and back every year. So why? This gets us to that bottom line. The why here is why we're going through the exercise. We want to export the spreadsheet medium into that dynamic software to build actionable plans, to build projections, KPI dashboards, automation, to keep the plan updated over time. And as I mentioned before, it's the columns that are the key. It doesn't matter how many you have. You can build this spreadsheet out 400 columns wide if you need to, just as long as the columns contain good data. You want data that you need at a depth of granularity that you can afford to maintain over time. It costs money to collect data and it costs money to maintain it. So be careful. Here's a glimpse into the future state. And as I mentioned before, can you visualize the kind of power that you possess if every row of data that you have down to a component level for everything of consequence inside of your horizontal portfolio, and you couple that together with your vertical portfolio? Having the right data at the correct level of granularity, it will take your organization to a new level of understanding and actionable planning. And that's even if you must continue to defer important things due to budget constraints. You'll be able to see all those important things in one place and make better decisions about the resources that you're spending now. And that means that you're evaluating the opportunity cost in a better lens instead of looking backwards at the opportunities that you've lost. You'll also be able to see how these decisions affect the decisions you'll need to make under another budget cycle, especially with limited resources later. So as you can see, there's a long-term strategy forming here. Once we've completed our spreadsheet exercise, we know what data we've got in the bag, and we know what we need to do because we have looked and done a gap analysis. We've understood what is missing. And so it's time to design the strategy for what we're going to do next. And I believe it was Benjamin Franklin, maybe it was Mark Twain, fail to plan, plan to fail. So no plan is going to be exactly the same, but certain things will be very similar. This is where you need leadership alignment and you need funding to come into play. Every strategy must balance those four things: the time, the cost, the scope, and the quality, the iron triangle that we spoke about. You can't change the emphasis of one without affecting the others. So the suggestion here would be to start drafting a solid requirement specification. You may want to consult with us and we can help you get this done. But define the scope clearly, show what's in and what's out. This will provide definition, expectations will be set, and you'll understand the balance that you decide on from the iron triangle because it'll relate to the scope. Secure your leadership support. It's got to be short-term and long-term because your leadership is going to control your funding commitments. They're going to need to be educated and shown that there's a return on investment possible. And I'll talk more about that in a minute. But if you set realistic timelines, if you have staffing plans, remember you're in a marathon here. This is not a sprint, and most of you know that. But you also are going to identify your integration points with your legacy systems, your GIS, your CMMS. Maybe you already have assessment software, but you are also going to need to be able to do QA, QC, and oversight for each of these. And a well-defined plan, it's going to limit ambiguity. You're going to be able to reduce the scope creep and make your program defensible and measurable. So this is our call to action. By this stage in the process here, especially in building strategic infrastructure improvement plan specifications, you should have a clear scope. You should have gained your funding approval, selected versatile technology platforms, and you may be bound to one that's not versatile. Maybe that's a reason to change because you're going to want to integrate with other institutional legacy platforms. Select your qualified team. That's already done. They understand this type of work. And also your internal staff has been prepped and they understand what it's going to mean to help collect the data, how to do QA, QC on that data with their institutional knowledge. Consulted your IT and your GIS teams, other software teams about sharing your institutional data. Some of this stuff is considered secure. You've got to know how to pass the information that you have to consultants if you're going to use them. especially for integration with other software platforms. So if you think you're ready to collect your data and you've got all these boxes ticked, before going all in, do a pilot. Test your forms, validate the data, review draft deliverables. A small pilot will prevent big mistakes later and let your team fine tune the workflow before you scale. Remember that doing a pilot isn't a delay, it's an investment in your accuracy. And once that pilot is done, now you're ready to go after and collect data at a scale. Once your data is collected and validated, the analysis of that data then becomes the ask. This is where your long-term plans, they start to take shape. This is data that's living in an ecosystem. It's not a static report. You know, we call this thing, when you have facility assessments in PDF format, it's the $1 million bookshelf. And that is not what we're looking to do here. We want to build something that is updatable in real time, that it shows measurable financial results, that you can plan for contingencies and escalation and adjust along the way. You also need to be able to prove return on investment for the cost of your infrastructure for long-term planning with a few short-term years. When done right, this plan earns continued institutional funding because the leadership can see that you've got a tangible payoff. You've got fewer emergencies, you've got lower reactive spend, you've got more predictable capital to forecast well out into the future. True stewardship, it means building budgeting for your entire life cycle. And that includes recurring cost, the renewal, the replacement cost, and end of life cost. This also includes escalation and cost of money over a 50-year period. Hopefully, we're looking at a 50-year outlook. Escalation, I want to talk about for a minute. It's a specific price change over time. And this has to do with commodities markets. They provide things that our building components are made from: copper, steel, oil in your asphalt parking lot, and also in your carpet inside the building. All of these things, the prices fluctuate daily. So that is where your escalation needs to become a factor inside of any model. Cost of money is about the time value of money itself. So if I put that another way for you, escalation refers to price increases of specific goods or services over time. While the cost of capital or the cost of money, it's the price of borrowing or using money. It might even be the money that you already have, but there is an expressed interest rate to that, and there's opportunity that you can lose with that. So escalation is driven by specific factors like supply and demand imbalances, technology changes, and it also includes inflation. A lot of people just talk about adding inflation, but that's not really correct, because there's more than just inflation inside of escalation. And the cost of money, it represents the opportunity cost or the interest or the capital. So around at third base here, and for the last segment of our time, I want to touch on redundancy, on risk, and on return on investment. With great data, you still can't plan in a vacuum. Critical systems, they're going to vary. Your campuses are all different, one to the next, and your risk tolerances are different. Risk and redundancy, they probably should be analyzed together. For example, you have a single feed primary electrical system into a site. It's a very different risk profile from one that has redundancy, like a hospital. The question is where can you afford a failure and where can you not afford a failure? Just by way of application of those 5 W's, we started with the who, and because every facilities team should have a consolidated infrastructure risk mitigation plan, they need to know who to call when there's an emergency. So your highest risk, that's the where. That's the best place to start with your internal data analysis and starting that spreadsheet that we mentioned a few minutes ago. I would have that in the front of your mind If you've not gotten into the type of thinking that you need that, step into it here. Evaluate your risk, and you've got to form action plans around it. This will make sense for everyone from your leadership on down. It'll give you upfront action, while the larger data collection of doing a horizontal infrastructure facility type assessment, that's going to take you some time. But this will give you action time upfront while you're doing those longer time frame efforts. And until those are commenced and until they continue, you'll at least have some actionable plans here. So is anyone else in the room a tool fanatic? I wish I would have used that as a poll question. I love tools. And it's amazing how these simple sayings are true, especially when you have the right tool for the job, how easy the task can be with the right tools. And then how next to impossible the same task is if you don't have the tools. So it's like using a wrench as a hammer, or a screwdriver, a chisel for a pry bar. Sometimes you're forced to use what you have, but even in this, there's just a bit of planning that could have put that specialty tool into your bucket. So hopefully we can finish our time together with an introduction of a few specialty tools. I love this picture. I think there were a couple of specialty tools that were used to put this facility together. If you don't currently have redundant infrastructure like what's shown here, and you're not feeding critical facilities, it's okay. This exercise may help you identify and prioritize your primary infrastructure. What to assess first, what to spend your limited resources on based on what would take your vertical assets offline, possibly jeopardizing life, causing a cascading risk event chain that could lead to possibly jeopardizing more life. So I'm not going to spend a lot of time here. I just wanted to make this information available for you. These are the definitions around system redundancy. And I want to talk about just adding on to our Excel sheet from beginning. Let's talk risk. You can color your headings a different color here, but the idea here is to put a template together as a risk register. Where can you afford to fail? Where can you avoid your failure? This is where a simple risk register can save you headache and dollars. I've included the next few slides. I want to demonstrate to you how to simplify an approach to evaluate your risks, and how to couple the mission of your organization, the criticality of assets with that redundancy and risk, and make strategic decisions about capital renewals and deferred maintenance. So let's start with this spreadsheet, and then I'm going to populate it here with some examples. With the intelligence that I've added here, I think it's fair to note that this is not a one-size-fits-all thing. I've added some descriptions and categories that may not apply to you, but the idea here is to get you thinking about the elements, what it would look like if you were going to build this out. The other thing too is when you add something like likelihood and impact, and you assign weightings, and I don't know, let's just use 1 through 5. We can simply multiply ratings, and this may just be a gut feel of your staff. Multiply them together and get yourself a risk score. And so I've added a risk heat map in the example here as well. So as you go through and you get lots of lines of data, you can see what's going on. So this type of data, this risk analysis data, it is really easy to put a visualization to. It's also easy for someone without all of the supporting data to understand the scale and understand the scale of that risk. There's a potential, though, you can put your finger on the scale, and you want to build rules around your subjectivity, have those in place. Scores and weightings, you want to have definitions in place for those, and keep them clearly the definitions clear, and keep them nearby. So Does anyone remember COVID? We place the seriousness of human factor aside for a minute, but who can forget what COVID did to our planning budgets? When costs escalated 35, 45% nearly overnight, everyone's capital budgets were just blown. So here's another rhetorical poll question. How many in attendance are optimistic that there will not be another COVID type of risk within the next 10 years? If you're maybe more skeptical and you think it's a possibility, my question then for follow-up would be, how are you currently planning for that risk potential? How many here are including any percentage number on their infrastructure for escalation for a type of risk event like supply chain failure? I would say probably not many. So those who are familiar with vertical assessments and the facility condition index, how that equation works, this is very similar. It's a relational equation for risk mitigation. I won't spend any time here, but wanted to make this available for you. It's the backdrop for the next couple of slides. So I want to take us into our next exercise, which is doing a pilot analysis on a couple of sample risks that I put in here for you. When you apply the ROI cost benefit formula that I just showed you on these risks based on a mitigating cost and how much the full replacement, the avoided impact cost would be, there's a $575,000 return on investment, near over 250 grand just in near-term risk mitigation commitments. If you look at the math, and I just wanted to have this for you, the formula for Excel is up in the top left above the black box there, so you can have that later. You can check the math. And, okay, you took that to leadership and you showed them, look, there's a real return on investment, but this will be new and it'll be unfamiliar for all of you. Leadership is skeptical of your dollar numbers. They're not convinced. Okay, so what if we consider doubling that mitigation cost? When the dust settles on that math, you're still over 320 grand in residual ROI savings. With that, you should be able to ask your leadership if they would consider allocating a small percentage of an ROI to a pilot program to fund a more holistic, proactive program if you're reactionary right now. And if you're successful, that is a great way to fund a larger effort. At the end of the day, the organization is going to spend 500, maybe more percent to react to each of these as an emergency. And then you multiply that by the factors of escalation, the loss of value on money that will be invested on the wrong things at the wrong times. If you feel like doubling down for fun, apply these same processes and math to your vertical assets and show exponential value and being proactive in the long term. Hopefully, this illustrates how risk mitigation evaluation is important. So, is it important to your organization? I hope so. This exercise can tangibly prove that there is a choice. Dollars are going to be spent in the near term, but substantially more dollars will be spent if risks go unchecked over time. And remind yourself that this is not just insignificant things like, stains on carpet inside of a building. These are actual risks that you're talking about. That you're trying to mitigate. So should you pilot an ROI analysis? Yes. I've seen directors use ROI calculations to gain a percent of annual spend just from the emergencies to convince their leadership to fund strategic infrastructure assessments and capital planning programs. So to wrap this up, my key takeaways are by making hidden infrastructure visible through structured data, proactive planning, and total cost of ownership thinking, you can turn deferred maintenance from looming crisis into strategic opportunity for sustainable risk awareness and capital stewardship. Let me say it another way. If you are using structured data and life cycle cost planning, we can transform deferred maintenance from financial risk into strategic advantage, delivering measurable ROI and long-term resilience. So we want to wrap this up. Looks like we've got a few minutes. If we want to break out into some Q&A, anybody has any questions?
Yes, Mark, we have a question that's come in from Matt King. And he says, in your experience, how much of deferred maintenance risk comes not just from asset condition, but from uncertainty in the system topology? For example, not knowing what electrical circuits feed which loads when planning upgrades. Could having digital verified electrical mappings change how we forecast renewal work or justify capital requests? Big question.
Yeah, it is a great question. It's a bit complicated, and I think that with if we don't have any other questions, I'll tackle it here. But I think that digital verification and electrical mapping, you need to have that. There are inside of those panels and inside of your switchgear, there's arc flash requirements, and those requirements, at least here in the U.S., those are tied to PPE and personnel safety, which means that if you don't have these types of things, you've got to reverse engineer everything that you have from your electrical primary all the way down to the last sub panels that are distributed to. So yes, that is absolutely necessary. You're going to need engineering help probably to do that. Does that answer the question?
Matt, if you just want to type in the chat, if you have any additional questions related to that question. I don't see any other questions coming in the chat. I will tell you that Mark's contact info is going to come up. And if you go back in and visit the deck or watch the webinar on demand, if you have questions for him, then you can reach out directly to him at his contact information he's going to share.
So thank you all again once for attending. Contact me directly, reach out. My contact information is here. Don't forget to visit the website. There's tons of great information at rothiams.com. There's a lot of different webinars like this one, a lot of different areas to engage in the data and the practice that Roth IAMS performs in integrated asset management strategies. Also follow us on LinkedIn. Hit us up there.
Great.
Thanks again.
And as mentioned in housekeeping, we will be sending out links to the deck and the webinar as well. Please finish the survey before you hop off.